open up here. Come on. Come on. Copy. Let's hop on here, paste there, Control V. Let's go. Let's go. All right, we are rocking and rolling. All right, let's see how many people pop in, hey? So what else did I need to do whilst we were doing this? So let's get into sketching parabolas, because that's the main thing. Oh, that's what I also needed to do. I needed to jump onto here and also jump onto, let me create a new tab. Pull that over here. So that's the only one I've got open. Go away. Oh, that's actually really annoying. There we go. Classwork. Edits, that's right, I needed to remind you guys. As well. Week 10, we will be doing the test on data analysis we were supposed to do in week 6. You will be given the test in week 10. You will have all week to complete the test. In terms of the test on data analysis, we were supposed to do in week 6. You'll be given the test during week 10. And we'll submit it via email or hard copy. Hey Josh, to the school. How you doing? You'll have all week to complete the test and submit it via email or hard copy to the school. All right. This will be the only math work for the week. So this will be the only math work for the week. That is to say there is Drew. Hey mate, supposed to be here doing some parabolas with you guys. I'll be back playing Red Dead Redemption. Ugh. You know what I've been into lately? Like actually what I stumbled across was Red Dead Redemption online roleplay with Vertigo. I don't know if you guys have heard of Vertigo before. He's an interesting character. I think my phone for the week. That is to say, there is next week we can work on some revision to have I muted my mic? No, I haven't muted my mic. Righto. Next week we can work on some revision to refresh your brains. Cool. Yeah. If you're still there, let me know if you're still there. I'll show you this roleplay series that I found. Like, it sounds really cringy, but Vertigo is he's pretty funny. He's pretty funny. He's a YouTuber. Let's edit. Delete that. Save. We want teams. I want files. So what files am I missing? If you want some help with parabolas, let me know. I'm just doing some other work in the meantime. If you have any questions, if you're stuck on any of the questions, let me know. We've been smashing this out for a little while now, so we kind of should be all over it. But a quick reminder, right? A quick reminder. Let's go back. Quick reminder. The big thing that we're focusing on, where is it? Is this guy here, the turning point formula, right? The turning point formula. And out of the turning point formula, our axis of symmetry, we can see where our axis of symmetry is, because that's a super interesting part of our parabola. We can see where the turning point is, righto, which is the coordinates of, or the values of h and k. And of course, remember, whenever we're calculating our parabola, we can always find the y-intercept as well too, righto. So these are some interesting points in our turning point formula of our parabola, right? Of our parabola. Like so. And so out of this, we have been working through a whole bunch of different questions, like this one here, question 5. State the coordinates for the turning point, right? We can see where it exists here in each of those down here. Sketch the parabolas, labeling the turning point and the y-intercepts. So we can go ahead and we can do a few of these. So there they are there. There's a few examples of the things that we were doing beforehand, like so. So today is just a mere continuation of that, right? That was our focus. These questions here were our focus last time. And on today, you can either continue working through those if you wish, all right, or you can go ahead and extend yourself with some of this. Write the rule for the graph if y equals x is transformed by the following. It's reflected in the x-axis. Ugh, that's messy. Translated 2 units to the left, translated 2 units down. Okay, so if we're reflected in the x-axis, oh, has my Apple Pencil died? I think my Apple Pencil's died. Surely not. Let's have a look, see. It's annoying. Are we gonna be plugged in? Are you gonna plug in? No, there it goes. We're live again. My iPad's been messing up today. Remember, when we translate, right? A different color. Reflected in the x-axis. Well, remember, a reflection is like a mirror image, right? And so if we're going to reflect it, this one is going to be y is equal to negative x squared, like so, right? Because remember, x squared looks like this, negative x squared looks like this. There's our reflection right there, like that. Alright. This guy here, translated 2 units to the left. Now, if we recall, right? If we recall, it's going to be y is equal to, our formula dictates when we're moving to the left, right? Is that it is, what did we call? X minus h, right? So that's our horizontal movement like that. So if that's our horizontal movement like that, what value is it going to be? To the left, we need a negative value. So if we're moving to the left, h is going to be on the coordinate of negative 2, right? So if we think about it, y is equal to x minus negative 2, like so. But that's not the best way we can represent it. It's going to be y is equal to x plus 2 squared, like that. Righto? Hopefully that kind of clears it up for you. Going ahead and answering some questions. Translated 5 units down. Well, that's pretty easy, right? Yeah, this one's easy to think. Y is equal to x squared, and if we're going down, we are going to minus 5 units. If we're going 4 units up, it's x squared plus 4, like so. Translated 1 unit to the right, well, it's going to be y is equal to x minus 1, okay, x minus 1, like so. Reflected in the x-axis and translated up too, okay? So if we're reflected, remember that's going to be a negative and negative a. And we translate it 2 units up, well, let's do this. So it's going to be y is equal to negative, all right, negative x squared. That's our reflection, like so. And we're going 2 units up, so we're going to plus 2. In the x-axis and translated 3 units to the left, well, here we go. Y is equal to, again, our negative, but when we're moving horizontally, we're adding or subtracting a value to x. So in this instance here, if we're moving to the left, it is going to be plus 3 units to the left. Translated 5 to the left and 3 units down. Ooh, here we go. So y is equal translated. So let's think about our lateral movement first. X left, so it's going to be a negative, which results our thing in a positive, like so. 5 to the left, squared. And then we want to go down 3, like so. Luckily, last translated 6 units to the right and 1 unit up. So of course, translating 6 units to the right, that's going to be a minus, because if we're going to the right, our h is going to be a positive value, like so. And of course, minus positive 6 results in a minus. And 1 unit up, we plus a 1, like so. And that's how we go. That's how we roll. Hopefully that makes sense for you guys. You can rewind and go back and check those answers. Demonstrate the rule for the following parabola. Now, remember, we have our turning point. So the basis of all our parabolas here is, of course, this is the platform for our parabola. Okay, it is y is equal to x squared, like so. Okay, the 3 features that we're looking for is we are looking for our dilation. We are looking for 1 and 6. Wow, crazy. We're looking for our dilation. We are looking for our dilation. We're looking for horizontal movement, and we're looking for vertical movement. So first thing I can notice here for our first guy here, we can see y is equal to. So let's write our formula out. Y is equal to ax minus h squared plus k. Okay, like so. Now, let's think about this. Let's start with our turning point. So our turning point is really easy. It is 0 and 0, right? And 0, 0. So given that our turning point is 0, 0, like so, we know that we can substitute a. X minus 0 is of course just x, so let's keep that as x squared. And then 0, because there's nothing added on the end. So we just need to figure out what a is, right? Now, the thing about in order to figure out what a is, well, we've got a few hints here as to guessing what a is. Now, in order to figure out what a is, all we can do here is we can substitute the values based upon these coordinates here, right? So let's figure out what a is. So if x is equal to 1, right? There's our x coordinate here. Y is going to be equal to 6, like so. Like, makes sense, right? So we can substitute these values into, I'll do it in green, into this formula here that we've got left over, like so. Let's rub this guy out here, like that. So when y is equal to 6, it's going to be a, not x, because it's a multiplied by 1 squared, like so. Well, now 1 squared is of course just 1, right? 1 squared is just 1, so let's just skip that step and go 1. A times 1 is of course just a, right? So a in this instance here is 6, right? It's 6. So now all of a sudden, given that we've figured out what a is, we know, well actually what I'll do is we'll write this out properly, right? So we can say, well, y is equal to a is 6. We know that our origin, our turning point is 0, 0, so we don't have a value added to x or subtracted from x. Nor, because this coordinate here is of course 0, 0, okay, we know this to be h and k. Given this is 0, 0, this ends up just being my formula, right? So we can use a whole bunch of things. So let's recap what we did. First thing that we did is we found we identified the formula. Let's do this a bit smaller and I'll zoom in. So a few things that we did. We identified the vertex slash TP formula. Alright, so we determined that y is equal to a x minus h squared plus k. Okay, we should be familiar with that. Second thing that we did is we identified our turning point. Our TP, and we substituted them into our formula. And you can see, right, there was our turning point right here, okay? A coordinate of 0 and 0. And we know our turning point to be the value of h and k, right? So here, at this point here, and I'll put this in green, we determined, after our substitution, that y was equal to a x squared, right? We worked at a is equal to x squared. Now, from here, I'm running out of room. I should have done this more organized, but you get the gist. Step 3. Here's what we did. We substituted given coordinates into our formula. Alright. So here were our given coordinates. I'll rub that out so I can reiterate it, right? Our given coordinates here. This guy here was x, right? When this guy here is x is 1, when x is 1, y here is going to equal 6, right? Y is going to equal 6. So we substituted those values, right? And then we went ahead and solved it. So we said, well, 6 is going to be equal to a multiplied by 1 squared. And then we eventually determined from that well, then y, sorry, not that. We eventually determined that through substitution that 6 is equal to a. We were then able to solve the formula, right? Step 4, solve the formula. Solve formula. Because we have figured out what a is, we've already substituted the turning point into our formula, like so. Now we're going to substitute the given coordinates of our formula, okay, to determine, I should write to determine a, to determine a, right, like so. And then we just solve the formula. So we figured it out that that y is equal to a, which is 6x squared, like so. All right, and it makes sense, right? Like if we think about it, we can just see this, like this formula here, or this parabola is pretty skinny, right? It's a super skinny formula, and we determine, like our dilation is determined. The bigger this value, or the bigger a is, the more skinny or narrow or less dilated our parabola is going to be. Right? Hopefully that makes sense to you, whoever's here. To whomever is here. I'd say most of year 10 is probably out, well, what Josh is playing games or doing anything but work, right? But cool, I just like these puzzles. These puzzles are interesting. Right? Puzzles are fun. Alright, let's upload some stuff. Oh, hey! I'm here, not understanding the subject here. Oh, right, hey, Kayla, you're here. Kiara, you're here. Not understand this subject here, but okay. Alright. Do you want to, we can start all over again if you like. That's fine, I don't mind. We can start all over again, like seriously, like if we go here. Like if we go all the way back to like here, right? When we did equations, we looked at here, oh, way back at the top here. We said like way back at the start, like the last thing that we did, or our first involvement in were linear equations, right? Where we took an equation like this, right? We considered this like a machine, right? So this here is my machine that makes things work, but I can put like whatever value I want into this machine and it's going to output me an output, right? So I can put 1 into my machine and it's going to give me an output. I'm going to put 2 into my machine, it's going to give me an output. And it's from these outputs that we then began to, actually, not that, that we then began to, let me get rid of a few of this bit here, that we would plot these in a table of values, right? We would go ahead and we would say, okay, actually, I'll do that. We would say, all right, let's put this. When I put x into my machine, I'm going to get y. 2, 3, 4. What were the values that I did? X is equal 0. So when I said if I put nothing into my machine, what's going to happen? If I put 1 into my machine, what's going to happen? 2, 3, and 4 into my machine, right? We said that, well, if I put 0 into this machine here, x is equal to 0. 2 times 0 is 0, plus 1 is 1, okay? So when x is 0, y is 1. When x is 1, 2 times 1 is 2, plus 1 is 3, y is going to be 3, and so on and so forth, right? We went ahead and we did this, probably year 7, definitely year 8, most certainly year 9. We went ahead and plotted this. We took our coordinates. So here When my machine is 0, my y is 1. When my machine is 1, my y is 3. When I put 2 into my machine, I get a 5, and so on and so forth. Here are my coordinates, right? 4 and 9, like so. And from there, I then went ahead and I plotted my values. I plotted each of these values on my plane. So where this is 0 and 1, I would go here, and you can see I've done this already. I'll make this smaller. There is my 0 and 1. When x is 0, x is 0, y is 1, like so. Over here, then I'll go 1 and 3. There's 1 and 3. When x is 1, y is 3, okay? X moves across, y is up, and then so on and so forth. So you can see that, and eventually what we learned is that we can create a straight line, like so. Using this, it creates a linear equation. Well, the thing is then we went next level, right? This is how I introduced you to parabolas. And then said, well, linear equations involve just kind of straight individual x's, individual y's, okay? There's not a lot of squaring numbers, squaring values. There's not a lot of double ups of this value here, like so. But what we determined is that parabolas involved the squaring of this, right? It involved the squaring of this x value. What happens if my machine, rather than as a simple straight line like this, is curved? What happens if I take my x value and I square it? Well, this is what we began to learn, right? We said, well, righto, if I put -2 into my machine here, -2 times -2 gives me 4. So I get a coordinate of -2 and 4. Same deal again here, right? If I have a value of -1, like so, I get an output of 1, like so, and so on and so forth, like so. So these guys act as my coordinates, like so. So it's a different machine altogether, which culminates in a different shape altogether. Most namely, we get this blue guy here, this parabola. Let me get rid of the red stuff here that I've done before, because we get that. And let me put these coordinates on. So my parabola says that, righto, well, let's start with -2 and 4. So -2 and 4 is, oops, that's not it. Let's go red. -2 and 4 is there. So there it is there. This is the coordinate of -2 and 4, meaning -2 across and 4 up. Righto? Down here, here's my next coordinate, which was -1 and 1. So -1 and 1. And then this guy down here was 0 and 0. Now, the interesting thing about parabolas, right, which makes them really interesting, is that they are a reflection, right? One at the turning point here, which is of course this green line here. I'll get it green. This turning point here, which is this guy here. Everything on the left-hand side of this turning point is exactly the same as everything over here is exactly the same as what's over here, right? You can see, I'll use orange. If I look at -1 and 1 here, it goes up 1 and across 1. Now over on the right-hand side here, it's the same deal. This goes up 1 and across 1, like so. Up here, you can see this goes up 4, and across 2. Same deal over here. This goes up 4, like that, and across 2, like that. So this is why we call it a parabola. This is what makes a parabola unique, right? Is that not only does it use a different formula, i.e. it squares the x value, all right, but as on account of it being squared, it creates this funny like U shape. Fun fact as well too, if this was like a negative x squared, like so, okay, as opposed to a positive x squared, it would actually look like this. It would actually go this way. 1, 2, 3, 2, 3, 4. It would actually be upside down. Same shape, but just upside down, like that there. Okay, So that's how we begin to get our formula. Now, here's where things got, hopefully you understood that, right? You understood how you get from this and you can plot it onto that. But now here's where the interesting part comes in, right? Because when it comes to parabolas, that's all well and good that we can conceptually understand what a parabola looks like. But now comes the point where we begin to manipulate and understand, well, what's happening in this formula here that causes it to do two things. We want to know, what can we do to this formula here? What can we do to the formula? What can we do to, and I'll use a different color for this. What can we do to y is equal to x squared that will do two things? That will change its position, okay? Change position, okay? Or change its shape, okay? Change its shape. Change its shape, right? These are the two things that we're focusing on. Changing position. When I'm talking about its position, I'm talking about its position on a Cartesian plane. Like, for example, what's going to result in the parabola being over here? What's going to result in the parabola being over here? Like so. Or what's going to result in my parabola looking something like this? Or what's going to result in my parabola looking something like that, right? They're the two things that we need to kind of think about. Well, what's going to influence, or what values are going to influence those changes in position or changes in shape? Now, if I go back to my linear equations, we came up with a formula, right? We came up with this formula. We said that y is equal to mx plus b. This formula here allowed us to understand those exact two things, right? It allowed us to understand its change in position on the Cartesian plane, and also probably to a lesser extent its shape, right? Because this formula here told us two things. It said that this value here, if we change this m value on our x, it changes the gradient, okay? Now remember, our gradient was like how steep something was, righto? So our gradient can look anything from like this to like, actually I'll put it on a Cartesian plane. My gradient can look into, actually let me just clean up my Cartesian plane just a little bit, like so, because we kind of get that part. Our gradient determined how steep something was, right? So it determined like, did my line look like this, or did my line look like this? Okay, how steep did my parabola, did my line go? And from that, we learnt that we could manipulate this m to change like its shape, right? To change its direction. Not only that, we also learnt, excuse me, we also learnt that this value here was my y-intercept. Now, this is important because it allowed us to understand where its position was on the Cartesian plane, right? So we were able to say, all right, I'll use green for this one. My y-intercept for this line here is down here. Okay, there was my y-intercept. So it told me that my position was down here, or maybe my y-intercept was like up here. Okay, it was there. So it told me that, well, its position was here on my Cartesian plane, right? So these were the two features that we looked at when we looked at linear equations, and these are the two features of our formula, i.e. our machine, because we kind of imagine this as our machine, right? These were the two aspects of our machine that we determined we could manipulate in order to identify the gradient, okay, or its shape, and our y-intercept, or its position, okay, in similar fashion to here, its position and shape. Now, when we looked at our parabolas, we started off with our understanding of our most basic parabola, which was, of course, this guy here, right? Was, of course, this guy here. y is equal to x squared. And we went ahead and we plotted it on and we said, okay, cool, there it is there. And we proved that by plotting it, right? But the thing is, this doesn't show us the parts of our machine that I can manipulate that will change its shape or position, all right? It's at this point here we introduced slowly, that we introduced, where is it? Boom, this guy here, all right? This guy here. So I'll get rid of this stuff here. Now, you've seen this before. I'm sure you have seen this before. This point here, this guy allowed us to identify the things that we can manipulate to this x squared, the things that we could do to this x squared or around this x squared, that allowed us to change its shape and position, okay? Namely, this guy here in red, this guy allowed us to change its shape, okay? But the word we actually gave it was our dilation, right? Our dilation. And we looked at this value here that we multiplied our square by. So you can see we've taken this value here. Let's do purple. This value here, and we're multiplying it by our entire square, like so. There's our square. Hopefully that's a little bit skewed, but hopefully you get that, right? We called this our dilation, and we said that we can manipulate this in different ways and we get different patterns, right? And we looked at it here, right? Here's a few examples. So there's our dilation, there's our A value that we're manipulating. So let's take this formula here. Our value multiplied by our square. We looked at our baseline one, which exists here. There's our baseline, our y equals x squared. And we said, well, there it is there. There it's plotted on red. That's our baseline guy. Then what we explored is we said, well, what happens if I add a 3 to my x squared or multiply my squared number by 3? Well, we learned that if we multiplied our square number by 3 like this, what happened is we got a much narrower or much skinnier parabola, okay? It changed the shape. It made it more narrow. We also learned that if we went the other way, if we started dealing in values of less than 1 but greater than 0, okay, as in fractions, what happened was it actually kind of spread out or opened up our parabola like that. So from here, we talk about dilation, but really this is just changing the shape of our parabola, right? Changing the shape of our parabola. From there, okay, that's all well and good. So that changes our shape of our parabola. We can tick that box. But what about these two guys? Here, these two guys here, these guys influence the position of my parabola, righto? Namely, okay, this first guy, this value added to x here, this part here. Actually, I'll do this on top. All right, this value here added to h. This guy influences horizontal movement. Okay, or that's our side-to-side movement. This here indicates how far the technical word and you'll see is translate, but ultimately it just means move, how far we move it like this way or how far we move it this way, okay? The other aspect here that relates to position is this guy here. This K influences vertical position or up and down. So how far up or how far down, right? And so we went and explored this. We explored this over here. So let's start with, and you can see here, we've done it before. We're going to add a K value, or we're going to add a value to our square here that looks like this. So again, we started with our baseline, which was y equals x squared, which we know in our red is our flatline baseline generic formula that we use. Then what we went ahead and did is we said, well, in green here, I'm going to add 2 to this machine. I'm going to add 2 to my x and see what happens. Well, we explored and realized that when I added 2 to my x, it actually moved everything up 2. Like there's my horizontal movement. in relation to my baseline x squared. By adding 2, I moved it up 2. So it resulted in upward. When I subtracted 2, like this, okay, when I subtracted 2, like this, it moved it in a downward motion, like that, right? There it is, 2 steps downward, like that, okay? From, oh, undo, okay? Hopefully that makes sense. So that gave us the understanding that, all right, well, this relates to vertical position or vertical, I should say, vertical movement or vertical position, right? Position. We then looked at the horizontal aspect, right? The horizontal aspect. We said that, okay, well, there's our baseline again, is our x squared. Our x squared here is in our red, righto? Then we said, all right, well, what happens if I take my formula, which is over here, like so. There it is there. There's our h. What happens if I put a -2 into my formula? Okay, so because if I put a -2 into my formula, it turns it into a +2, like so. If I substitute -2 into h, well, if I move -2 into h, you can see it results into a sideways movement, 2 places to the left, 2 places to the negative, right? I then said, well, righto, okay, what happens if I just add a +2? Okay, because a +2 results in a -2 there, like so. Well, if I add a +2 to my h, well, then you can see I move 2 spots to the right. I know. Does that make sense? So from there, this here results in a change, a vertical position change, like a horizontal change, like so. This here performs the lays the platform or our understanding for this. Where is it? I've lost it. For this formula here, right? Our entire focus with parabolas is all about our ability to manipulate its shape. Well, I'll get the marker. Its shape and its position. And we can do that by applying this aspect and this aspect to manipulate its position, or manipulating this to change its shape, righto? Not only can we do that to this formula to do that, but what happens is that the patterns that emerge, right? We can decide and we can say, all right, well, we can, by just looking at the shape of this formula and go, well, here, this is my axis of symmetry. So this here is my x-axis. This tells us that the axis of symmetry is exactly this point. It's the point at which my parabola is being reflected, right? I did up here. So like here, I said to you that this line here indicates the point at which everything on the left-hand side mirrors everything that's on the right-hand side, right? So this here was called my axis of symmetry. Axis of symmetry. Symmetry, like so. Alright, and this formula actually gives us, where did you go? Just under here. This formula actually gives us, gone too far, actually gives us the axis of symmetry. It says that, hey, whatever value is in here, whether it be positive or negative, is going to be my axis of symmetry. More so, probably the most important point here, right, that speaks to its position on the Cartesian plane is the turning point. The turning point gives us a really solid understanding of where it's positioned on a Cartesian plane, right? Like if I have any Cartesian plane, like so, all right, if I know the turning point is here, I know my parabola can look something like this. If my turning point is here, I know it's going to look something like this. If my turning point is here, I can know it looks something like this. So using this as a set of coordinates, because I need you to know that this here is a set of coordinates, all right? Coordinates. This is the set of coordinates that tells us exactly where the turning point is. So here, my turning point's not to scale. This down here would be HK. This here would be HK. this over here, my turning point would be HK, like so. And then finally, this is just an assumed bit of knowledge, right? We can also identify the y-intercept. We can substitute x with 0. Okay, we can substitute x with 0. Substitute means to replace. So replace x with 0 to determine where the y-intercept is. Now, I don't know if you remember, but we talked about the y-intercept up here. We talked about the y-intercept up here as a means to identify its position on the Cartesian plane, right? So we can use that. So you can see down here in red, our y-intercept is right there. And so you can even see in our formula that this ends up being, well, when x is 0, we can calculate our y-intercept. This begins to form our basis of understanding of parabolas, right? Our ability to manipulate these things in different ways to change its position and to change its shape on a Cartesian plane, like so. And this is from which all of our questions begin to unfold. So let's have a look at, I won't answer them today, right? But we can, like this one here, state the coordinates of the turning point for each of these graphs, right? So given that we know that our formula is for our parabola is equal to this, x minus h, I'll give more space, I'll zoom in. Our formula is y is equal to a x minus h plus k. We can begin to recognize and see the patterns that exist here. So let's have a look at like this question here. You can see in this formula here, right, where h is and where k is. Like h is this value here, k is this value here. So we can say that the turning point for this formula here, so its position on the Cartesian plane, is going to be at the coordinate of 3 and -5, like that. All right. If we have a look at this guy here, like so, well, we can see that it has this coordinate here. Okay, now this has got a +2, so that means that's going to be a -2 for that coordinate, and -4. So my turning point for this guy is going to be -2 and -4. That's the point or position on the Cartesian plane at which its minimum point is, its turning point is. And so that's what we're kind of interested in. And that's just one example of how we can use our formula to look at its shape and look at its position on a Cartesian plane. I know I went over time, but I kind of want to be as thorough as I possibly could without overwhelming. All right. If you go ahead and you learn that, I forget about this, I'm not sure how to do this, well, come back and ask me. I'll keep explaining it, right? I'll keep explaining it in different ways. I'll use different examples. I'll manipulate it in different ways. I don't know. But just remember, right? You can think of this as a machine, and we're just looking at how this machine looks on a Cartesian plane, like so. How can I use the values that exist in my machine already to determine its shape or position on a Cartesian plane? In similar fashion, how can I use the values that exist in this formula here to determine its shape and position on a Cartesian plane? All right. If you're still confused, let me know, and we can give this a go next lesson. All right. But notes, look, we're not going to be tested on this. We're not going to be tested on this, but it's a fun thing to do, I guess. All right. No, you're welcome. Did that clear anything up for you at all? If it didn't, you can tell me, that's fine. It won't hurt my feelings. think so, yeah. Look, it just comes down to practice now, right? Like, it really does. It's just a matter of understanding the language, understanding what the questions are asking, and just mucking around with it, right? Just mucking around. Remember, the answers are... Have I put the answers up? Please tell me I put the answers up. Like, so if you decide to go back to here and look at Introduction to Parabolas, please tell me, did I put the answers up? Yeah, I did. So you can have a look there. Did I put the answers up here? Did I? Oh yeah, I did. So you can use the answers to help you, you know, conceptualize your understanding as well too. Use all the resources at your disposal. Maybe you might want to like look at the answer first and then go, oh, how did they get that answer? And work backwards from there. Like, there's a bunch of different ways, you know, you can learn. Anyway, I appreciate you kind of hanging out and coming. Like, yeah, you're the only one, and you kind of I really admire your tenacity and your perseverance. It's it'll hold you in good stead in years to come, Kiara. And I thank you for coming out for last period on a Friday. You're unreal. You too, Kiara. Be good. Good job. Alright, let's end the stream.